Lesson 10.2, we are finding arc measures. Now, the word arc, I'm sure you could guess on a definition of what an arc is. So right now I'd like you to just think about, what does that mean? Arc. Arc. Think about arc. I think about basketball, okay, because I'm a sports guy. I played basketball. When I would shoot a basketball, or when I'd shoot like a line drive at the rim, my coach would always tell me you need more arc. It needs to go above the rim to go into the hoop. So arc is around the circle, right? Arc. It's that curvature of the circle. Just going through a couple definitions here. Central angle. Central angle is going to be very important in lesson 10.2. This is an angle whose vertex is the center of the circle. Okay. A circular arc is a portion of a circle as shown below. The measure of that circular arc is the measure of its central angle. So right here, this circular arc from A to B is measured by the angle it creates with that vertex in the center of our circle. Okay. If that angle, like you see down below, is less than 180 degrees, then it is called a minor arc. Okay, I bet you can guess if it's above 180, what we're going to call that. It's going to be a major arc, yes. Okay, and it is denoted by AB. So this is a minor arc. That's how we label a minor arc. We'll get into major arcs in a little bit. Just for an example of how we measure a major arc right now, I want to measure this from B to C. I just want to know what that angle is, or how we measure that arc. We're going to go to angle, and click on C. Oh, we're going to delete that one. We're going to go from C to A to B, and it's 59 degrees. So that's how we measure arcs. All right. We have defined central angle and minor arc. Let's define major arc. Okay, for an example of a major arc, this is a major arc. If I have not ARO, ARC, there we go. We have a central point here, and let's say we have point A, let's say we have point B, then let's say we have point D, let's say way over here. Okay. This here is a minor arc. The major arc of AB has to go through D. So A, D, B. And that's how we would label that. It would go like this. And that would be a major arc. Okay. Next one is semicircle. A semicircle is an arc with endpoints that are on the diameter. minor arc. Remember, a minor arc is less than 180 degrees. A major arc is greater than 180 degrees. Okay? And a semicircle is equal to 180 degrees. Okay, the arc of a semicircle is 180 degrees. Okay? We defined the measure of a minor arc. Remember, that's just the central angle. You just have to find the angle that's in the middle of the circle. The measure of a major arc is the difference of 360, because that's the measure of a circle, right? 360 degrees around. And the measure of its related minor arc. Again, for example, I have a circle here. Here's my center. I have a point here, call it A, a point here, call it B. Let's say this is 30 degrees. Okay, just as a reference, point D is over here. The major arc would have to be 360 minus 30, which is 330 degrees. That's the difference. Adjacent arcs, I bet you can put a definition to that, right? We know what adjacent means. Adjacent arcs intersect at exactly one point. Arcs that are right next to each other. Okay, we're going to get into the next three definitions down below. We talked about this earlier. This is good. Here's an example of a major arc. This is how we measure. The measure of arc ADB is equal to 360 minus 50 degrees. That'll give us 310. Okay, but understand, look at the way we name a major arc. Look at the way we name a minor arc. See the difference? Okay. Arc addition postulate. I don't think we have to describe this. I think this is pretty common sense. The measure of AB plus the measure of BC would give us ABC. Okay, I think that's pretty obvious. Congruent circles. Two circles are congruent if and only if they have the same exact radius. If they don't have the same radius, they are not congruent circles. Congruent central angles. In the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding angles are congruent. Again, we have vertical angles here. We've talked about vertical angles in the past. Okay, those are congruent central angles. And then similar circles, all circles are similar. Alright, some extra practice here. In 1 through 8, we have to identify the given arc as a major arc, minor arc, or a semicircle, and then find the measure of that arc. Number 1 is AB. The first thing, is that a minor arc or a major arc? Is that less than 180 or more than 180? That is less. I'm going to say minor. Alright, let's just go through and label all of these as minor or major. ABC. Guess that is a semicircle. Again, let's look at what they give us here. They say AC is perpendicular to BE. So AC is a segment that's perpendicular to BE, which means this is a right angle, that's a right angle. So AC is a straight line, that's our diameter, so ABC is a semicircle. Okay. ABD, all the way down here, that is a major arc. BC, that is a minor. BAC goes all the way around, that's a major arc. Okay, DAB, another major. AD, it's a bigger arc, but it's still a minor. And then CD, right here, minor. Okay, now let's find the measure of each one. So AB, we talked about the information given here that this is perpendicular to this, so we have a right angle. So this is 90 degrees from A to B. ABC is a semicircle, so that has to be 180 degrees. And let's start labeling these. Yeah, 90, 90. We have to figure out what AD is. No, not yet. ABD adds all our measures up. 90 plus 90 plus 40. 180 plus 40, which is 220. And BC. BC is here. We know that measure. It's 90 degrees. BAC. Okay, BAC goes all the way around, B to A to C. We know this is 90. We know this is 90. We don't need it. We know this is 90. Okay, we have to find this angle here. Okay, we do that by taking 360 minus 90, minus 90, and minus 40, all of our angles. And if I do that, 360 minus 90 is 270, minus 90, minus 40. 270 minus 90 is 180, minus 40 is 140 degrees. Okay, so I know this angle here is 140. So to find BAC, we have to take 90 plus 140 plus 40, and that'll get us, I think, 270. Next angle, DAB, which is 140 plus 90, which is just 230. AD, I already found that angle, it's 140 degrees. And CD, which they give us, is 40 degrees. So it's really just a bunch of simple addition or subtraction to find each angle. And moving on. Oh, number 9 deals with the circle above here. Tell whether ABC is ABC right here. Is that congruent to ADC? Okay, now we knew the measurement. We knew this was 90, 90, and 140. Okay, so ABC is 180 degrees. That was our semicircle. And ADC is 180 degrees. Okay, so yes, both are semicircles. Number 10. In circle K here, find the measure of DE. DE is right here. Now we have to do some math, some findings here. We know this is 55 degrees, and we have a vertical angle here. This angle, which is 55 degrees. I know that CE is a diameter, so CE, we're just going to label this, is equal to 180 degrees. Sorry, the arc of CE is 180 degrees. So all I have to do is take 180 and subtract 55 to get angle, or arc DE, which is 125. Number 11, the last problem here, find the value of x, then find the measure of AB. So first, let's find the measure of x by taking all of our measures and adding them up to 360 degrees. So 40 plus 70 plus 75 plus 2x plus 5x is equal to 180 degrees, or sorry, not 180, 360. Okay, combine like terms, we have 7x here, 40 plus 70 is 110, plus 75 is 185. Subtract 185, which is 175, is equal to 7x. Divide by 7, 175 divided by 7. 2, 14, 3, 5 is 25. So x is equal to 25. Okay. We found the measure of x. Now I have to find AB. AB. Just have to plug x in right here. 5 times 25 is 125. That's 10.2. If you have any questions, please send me an email, talk to me during class, wherever it may be.